It is gravitational field at a point due to a cavity made in a spherical solid sphere. So what we are looking here is a solid sphere which is made with a cavity. What you are seeing here, this is the cavity. Okay, so this whole thing is the solid sphere, and there is a point which is lying just along the axis. What I am drawing here, some point P which is lying at certain distance, and here is the center of the big complete sphere, say O, and here is the point O dash, which is the center of this smaller sphere, whose the surface is touching the exterior part of the big sphere, and another surface is touching the center along the axis, what you are seeing. That means if the complete sphere is of radius r, and this one which is the smaller sphere, it should be of radius, you can easily guess, so this complete diameter of this one is r. That means this much it should be r by 2. So the radius of this cavity is r by 2. That means this much part has been removed from complete sphere. I may assume the mass of a complete sphere, right? So a complete sphere is m, and whose density is constant. Okay, so whose density is constant. In this derivation, we don't need any symbol for the density term. So for that, I am simply saying density of this whole material is constant. And now I have to choose certain distance which is measured from this center, okay, to this point, say A. This distance is A. Well, so now I have to find the net gravitational field at this point P only due to the remaining part of the sphere, that means with cavity. So at this point the gravitational field, that is Gp, so it is equal to gravitational acceleration due to gravity or gravitational field. The two terms are same. Okay, so this G due to the complete sphere minus gravitational field due to the removed mass which is causing the cavity. So now I am simply using the magnitude further, just saying G sphere and G removed are acting in same direction, both are acting in the same direction like this. So for this, we simply make use of the magnitudes of all these things together. That means Gp should be is equals the gravitational field due to the complete sphere is given by G, right? So which is G capital into m divided by the distance from this point, that is O, to P is A, so it should be made squared, minus, so acceleration due to gravity, otherwise gravitational field due to the removed mass, what you are seeing here, so that should be calculated. For that, so what I can do is the mass of the removed portion is equal to, okay, so what I can write is, that is otherwise I can say is proportional to the cube of its radius. Its radius is r divided by 2, should be made cube, and mass of the complete sphere is proportional to r cube. So when you divide these two things together, okay, on dividing these two, we get mass of the removed, okay, so this one, mass of the removed part divided by mass of the complete sphere is said m capital, so which is equal to, right, r divided by 2 and divided by r whole cube. This can be written, otherwise this is 1 divided by 8. I can simply say further, so the mass of the removed portion, say it is small letter m, which is equals capital M divided by 8. This will be the result for this one, mass removed from this cavity, okay. So this portion should have this much mass. So now I am using that term of mass here like this, g into, it is m divided by 8, okay. So whole divided by, what should be written in the denominator? It should be the square of the distance between the center of this sphere, the smaller one, should be removed later. So now whose center is lying at O dash and point under interest is P. So this distance from here to here, this should be, okay, so a minus r by 2, this should be this much distance, okay. So that I should use here in this part of the equation, that is a minus r divided by 2 should be made squared. So further what I can do is, I can take out some of the things outside. Before that I simply make a small revision here, that is gm divided by a square minus g into m divided by, okay, so 8, and also I am taking a square as the common term inside, I mean a outside, when I take it, so it becomes a square, and inside bracket the terms which are left is r divided by 2a should be squared. So now I can take out gp is equals, I can take out gm divided by a square as the common term in these two terms. So that means 1 minus 1 divided by, right, so 1 divided by, what the things left, it is 8, in the bracket it is r divided by 2a whole square. So this should be the result of our derivation, and this will be the acceleration due to gravity. Otherwise the field, gravitational field at this point P, which is only due because of the cavity which is produced, that is that means to say, so if this is the complete sphere, and when we remove this much mass, okay, so when we remove this much mass, only this much mass is a remaining, okay, whose shape is something like this, it's the cavity, and okay, so the line of action is here, so here is the point P, and now acceleration due to gravity due to this sphere with cavity is acting in this direction, this is gp. So gp is acting towards this cavity like this, so this is how you have to observe and remember this equation.